All right, so this is section 6.6. This is numbers 5 through 12. From the PowerPoint, we're using a normal distribution to approximate a binomial distribution. And what this entails is using what's called continuity correction. Binomial distribution is discrete data, things that are usually whole numbers. A normal distribution, continuous data, things that could conceivably have decimals. So the most challenging part is getting the right area. All right, am I going left? Am I going right? What's my lower bound and what's my upper bound? When it comes time to actually do these problems on a calculator, the calculator will you'll input the n and the p, which is your mean, n times p, and then the standard deviation is solved a little differently, but your calculator can handle that. It's the square root of n times p times q. You'll be given n. If you know p, you can subtract p from 1 and you'll know q. So let's begin. First thing is reading a problem. Probability of more than 8 senators who are women. What I'm going to do here is to write this as an inequality. More than 8. I'm going to say x greater than 8. All right, more than 8. Where I draw my line to indicate my 8 on my bell curve doesn't really make much difference. But here's what I'm going to do. I'm going to draw a line. I'm going to put an 8 here, and I'm going to continue my line down here. Notice, I didn't want to put 8 on my horizontal axis here. Now, continuity correction calls for me to subtract 5/10 from 8, giving me 7.5, and add 5/10 to 8, giving me 8.5. All right. So x greater than 8. I know I'm going to my right. Now the idea is, where do I begin? Do I start at 7.5 and go to my right, or do I start at 8.5? More than 8. X greater than 8. More than 8 does not include 8. So if I started at 7.5 and went to my right, I go right over the 8. I would include 8. So I want to begin at 8.5 and go to my right. All right, so what I'm doing here, I'm looking for this area right here. All right, so this is a case where my lower bound would be 8.5 and my upper bound would be 99, and I'm in business. Number 6, probability of at least 2 tickets this year. At least 2 tickets. At least 2 means 2 or more. So as an inequality, I'm writing this as x greater than or equal to 2. At least 2 implies x is greater than or equal to 2. Once again, where I draw my 2 for a reference point doesn't make much difference since I don't know the mean, but notice I'm not putting 2 here. If when you're doing this, you're using a whole number for your lower bound or your upper bound, you are doing it incorrectly. It's got to contain some sort of a decimal ending in 5/10. Subtracting 5/10 from 2 gives me 1.5, and adding 5/10 to 2 gives me 2.5. Now, x greater than or equal to 2. That includes 2. So I very well can't start here and go to my right because I wouldn't include 2. I've got to start at 1.5 and go to my right. So I'm looking for all of this area here. All right, so my lower bound would be 1.5 and my upper bound. Now, here's the deal. What happens here, sometimes people, their hair catches on fire because, oh, it's greater than or equal to. Why are you starting at 1.5? Whenever you have a greater than or equal to, or a less than or equal to, your graph is not going to match up with your inequality, but trust me, you're doing it correctly. Because of continuity correction, I got to start at 1.5 here. Greater than or equal to 2 includes 2, so I got to start at 1.5. So whenever you have a greater than or equal to or less than, it's going to seem like it's not agreeing with what you're actually finding, but trust me, it's correct. So this is my lower limit, and this is my upper limit, and you put those values into your calculator, followed by the mean n times p, and the standard deviation, the square root of n times p times q, greater than or equal to. All right. Number 7. Probability of fewer than 5 passengers. So as an inequality, I'm saying x is less than 5. All right. Probability of fewer than 5. X is less than 5. And once again, where I draw my 5 doesn't make much of a difference. Making sure you don't put 5 down on this horizontal line. If you're using, once again, and if it comes time to figure this out on a calculator, you're using a whole number in section 6.6 for a lower or an upper limit, you're doing it incorrectly. So continuity correction tells me to subtract 5/10 from 5, and then follow that by adding 5/10 to 5. All right, first thing I do, I'm less than. I know I'm getting smaller. Now the question is, does less than 5 include 5? No, less than 5 does not include 5, so I can't very well start here and go to my left. I've got to start at 4.5 and go to my left. If I started at 5.5 and went to my left, I'd be going right over 5. I'd be including 5. No, I want values that are less than. So I'm going to start at 4.5, go to my left. So this is going to be my lower limit, and 4.5 would be my upper limit. All right, number 7. Number 8, probability the number of students who are absent is exactly 4. These exactlies, I'm going to write this way, x is equal to 4. These exactlies are the easiest problems. Once again, I'll start out by drawing a vertical line, which indicates where 4 would be. Here again, it could be anywhere over this continuous span, doesn't make much of a difference. Once again, I follow through with continuity correction. I subtract 5/10 from 4, 3.5. And I add 5/10, 4.5. Now, the exactlies are easier because it's everything that's between 3.5 and 4.5. This is your lower limit, and 4.5 would be your upper limit. The exactlies are the easiest. It's all the area in between. Number 9, probability of no more than 15. All right. So 10 is good, 11 is good, 12, 13, 14, 15 is good, but 16, 17 are not good, and 18. No more than 15. All right, so x is less than or equal to 15 as an inequality. All right, so I draw my vertical line. I put in my 15, and continuity correction tells me to subtract 5/10 from 15. If I slide this up a little bit, 14.5, and draw another vertical line. Folks, if you're doing this and you're not drawing these bell curves, all right, there's no way you can do this in your head. You got to draw the curve. All right, less than or equal to. So I'm going to my left. Now the question is, does less than or equal to include 15? Well, yes, it does. So if I start here and go to my left, I'm not going to include 15. I've got to start to the right of 15, which is at 15.5, and go to my left. So I'm starting here and going to my left, all this area here. So this is my lower limit, and 15.5 is my upper limit. All right. Now, here again, notice that this is a less than or equal to. So you're saying to yourself, well, I'm starting at 15.5. 15.5 is not less than or equal to, but this will always happen. It'll seem to not agree because of the equal to part. It doesn't happen with a greater than or less than. It just happens with a greater than or equal to, or a less than or equal to. When you draw your graph, and it's not going to seem like it's agreeing, but that's the whole concept of continuity correction, when you have a less than or equal to, or a greater than or equal to. So be aware of that. Don't let your hair catch on fire. And these here, I'm not even sure you're going to see this on an exam, but it's part of the PowerPoint. So between 12 and 16 inclusive. So here's what's happening here. Inclusive, equal to, equal to. All right, between 12 and 16. Inclusive means you're including the 12 and you're including the 16. So what I'm going to do here, I'm going to draw a line here, call this my 12, draw a line way to my right, and label that 16. And then once again, I've got to do continuity correction. 11.5, subtracting 5/10, adding 5/10, 12.5, and the same thing with the 16, subtracting 5/10, and then adding 5/10. These are pretty straightforward. X between 12 and 16 inclusive is everything from 11.5 to 16.5 because I want to include my 12 and I want to include my 16, so I'm talking about all of this area here. If I can shade all of this in. So what we've got here, this is my lower limit, 11.5, and this would be my upper limit. This is the whole key to this, is getting the right lower and the right upper. Excuse me. That was number 10. Number 11, basically the same thing as, same idea as number 10. Between 5 and 9 inclusive. So X is between and including the 5 and including the 9. Between 5 and 9 inclusive. And once again, I'll start out by drawing my lower 5. I'm not marking it. I'm not marking it here. It's just a point of reference for me. And going all the way to 9. Here again, I'm not marking it on the vertical. Sorry, the horizontal axis. Get my verticals and horizontals confused. So subtracting 5/10 and then adding 5/10. Same thing with the 9. This would be 8.5, and then this is 9.5. And it was the case because it's inclusive. It includes the 5, includes the 9, everything in between. I've got to start at 4.5 to include 5, and I got to end at 9.5 to include 9. So it's everything from the lower limit, if I can shade all of this in, it's everything from 4.5 all the way out to 9.5. So this would be my lower limit, lower bound, excuse me, and then this would be my upper bound. Talking calculus over here, limits. And the last one, exactly 24. Well, here again, the exactlies are the easiest in my estimation. Here's my 24. Subtracting 5/10, I get 23.5, and adding 5/10. 24.5. All right, the exactlies are the easiest. It's everything between 23.5 and 24.5. So this would be your lower. And this is your upper limit. And if you're doing this on your calculator, you would put in your mean, n times p, and then standard deviation, square root of n times p times q. Hopefully this was helpful.